Hello and welcome to a new series where I'm taking a technical deep dive look at some of the components and systems for my project, my 1985 American Motors Eagle that I'm in the process of rebuilding. So here's the purpose of this video. I'm going to walk you through the front suspension. I'm going to talk to you about the design, how everything's supposed to work, and I'm going to show you exact part numbers, potential replacement parts, and we're going to discuss how to make those things which are no longer sold or produced anywhere. So let's get right into it. First, an overview of the suspension and its components. It's an independent front suspension, an IFS. It uses two control arms, an upper control arm, which is mounted to the body of the vehicle, and a lower control arm, which is mounted to the subframe. The subframe also holds the engine, so it's all one big piece of steel that this is bolted to. Now the suspension has three adjustments on it. There's toe, which is it's more steering than suspension. There's camber and there's caster. Camber is adjusted here using an eccentric bolt on the lower control arm to physically push the lower control arm toward and away from the vehicle. And caster is adjusted here at a piece called the strut rod. The strut rod supports the lower control arm. But let's go through these components one by one. First, the upper control arm. The upper control arm uses two bushings. This is where the spring sits for the vehicle, and this is where a ball joint sits. Now it's very fair to call this an A-arm, if you like to use that term. The lower control arm is a little bit different. It uses a single bushing, but it too has a ball joint. And this is a mounting point for the sway bar end links, as well as the strut rod. Partially boxed, this is a very heavy, hefty component. On a GM vehicle, this might be called the brake reaction rod, or something to that effect. To most others, Fords, AMCs, it's a strut rod. The front of the suspension of the Eagle uses a coil spring on either side. And this coil spring sits on the upper control arm. However, there's an intermediary piece that the coil spring is attached to that then bolts to the upper control arm. Now there's not much to say about this spring. There's some variance, I believe, for what type of engine was used in the Eagles. I'm not going to worry about replacing that or modifying it or anything like that. But this piece that supports the coil spring is called the spring perch or spring saddle. Most vehicles of this style of suspension use something like this, although this one is specific to AMC, much like the control arms and the coil springs. Originally, this space in here was filled with rubber. It was a special type of bushing. And this pin was bonded in the center. And what this does is this supports the coil spring and the weight of the vehicle and allows the coil spring and shock, which is also bolted to this, to remain vertical as the upper control arm pivots. This can pivot opposite and keep everything in line. That prevents the spring from having to bend and the shock as well. This bushing that was in here is no longer produced. As far as I'm aware, there are no replacements for this, but we'll get into that a little bit later. Now, this is a sway bar, or anti-sway bar, if you want to be real specific. Sway bars are pretty much the same on every vehicle. If you've seen one, you've seen them all. As far as I'm aware, every Eagle came standard with a front sway bar. At the end of the sway bar is the end links. These components contain a couple of bushings, and they attach at each side to either lower control arm. There's one more component that's part of the suspension, but it's not really part of the suspension. And that's the hub knuckle assembly. This is where the wheel mounts on this side, and then this is where the ball joints mount, the upper ball joint and the lower ball joint, as well as the tie rod. We're not going to get too far into that. If you'd like to see a rebuild of that component with new bearings and seals, I covered that in part 1 of the rebuild series for this vehicle. All of the factory bushings on the Eagle and every AMC were rubber to begin with. So I'm starting from the perspective that the replacement should also be rubber. Now there's a number of polyurethane and other components out there which we're going to talk about, but for the time being I'm going to give you direct rubber replacement part numbers. Let's start with the easiest one, the lower control arm. Now this is a single bushing, and luckily it's a direct part number crossover with a number of GM vehicles. LeSabres and Camaros and Firebirds and Buicks and Oldsmobiles and GM, so copy paste, you know how they do. The part number is Moog K3113 or AC Delco 45G 9026. It's a simple bushing, it's rubber. Good quality. Press in. All the bushings on the Eagle are press in style, give or take. The upper control arm is a little bit different. It uses 2 bushings and they're unique. They're AMC specific. But they should fit basically every AMC from 1970 up until the end of the company in the 80s. The part number is Moog K3096. And these are something you got to be careful of. The bushings are identical, but the one on the front needs to have this retaining ring pressed on the backside to hold it in place. Wait, hang on a second. It's actually the rearmost bushing which gets the extra retaining collar, not the front one. Let's move on to something a little trickier, the spring perch. Now we already talked about that the spring perch was originally rubber and somewhat unique. Instead of a sleeve on the inside of the bushing, this pin was bonded in place. Now, these are not available. They were at one time, a number of manufacturers sold them, and they've since disappeared from the market entirely. Now there are companies out there that can convert these to something like needle bearings or bronze plain bearings, but that's going to require modification to the saddle or the perch itself, which makes it a little bit tricky if a company ever does come out with a replacement bushing, because you never know. So I like to keep as much of this original as possible. And I came across an old forum post from something like 2006, 2007, referencing something called the John L. method. You see, he located a replacement part number from Energy Suspension for a polyurethane bushing. The part number is 2048G, and that's just one of these bushings. But that can be a little bit tricky to get. You need 4 of these, and ordering 4 of these part numbers can be annoying. Luckily, there's a kit available which contains 4 of these. It's 4.2132G, and it's supposed to be for a rear spring frame shackle, is what it says. Not sure of the vehicle. The wonderful thing is that this requires no serious modification. You simply melt out the old rubber like you would when you're installing any kind of polyurethane. These pop right in. The pin goes into that. Put one on the other side, push this pin all the way through, you're good to go. The nice thing is that these bushings don't actually touch or meet in the middle. They don't need to be cut down at all. And it gives you a perfect place to drill and tap for a zerk fitting so that these can be relubricated, as well as a reservoir on the inside for the grease to sit in. Which is wonderful because taking these apart to clean and re-grease them is a serious pain. Compressing these large coil springs on the Eagle is very annoying. Now let's move on to some bushings I'm a little bit unsure of. The sway bar bushings. Now there's end links that are mounted at the end of the sway bar, and they have bushings in them. But there's two bushings that mount the sway bar to the body or frame of the vehicle. And there's one of them right here. There should be an identical one over here on this side. Now, I know from measuring the sway bar that it's 15/16 of an inch. I don't know in thickness, in diameter I should say. I don't know if there was different sway bar sizes for different engine or transmission options in the Eagle. Mine is a wagon from 1985, straight six, T5 transmission. What I can tell you is that I purchased a kit, a bushing kit that was supposed to contain every bushing from Profane, polyurethane manufacturer, some time ago. And they came with these style of bushings. You can see that these have a ridge in the center. Now, the original bushings that were on this vehicle, and I have every reason to believe they're the original rubber considering their terrible condition, they don't have a ridge in the center. They've got two lips on the outside. The bracket that holds them in place looked like this. No protrusion in the center to allow that knuckle. And this doesn't fit. Now, I started looking for replacements, and I found it difficult to find rubber replacements. So I started looking for something else, and I came across these. Now, this is a universal kit from Energy Suspension, part number 9.5160G. It's a kit of sway bar bushings and brackets that's supposed to fit 15/16 of an inch diameter sway bar. Now, these two contain bushings of the original style, with the lips on the outside and no central protrusion in the middle. Now, because they're polyurethane, they need to be lubricated, and luckily Energy Suspension thought of that. There's a Zerk fitting already installed in these bushings with this nice little plastic cap on it. In addition, the bushings have been formed and probably drilled so that they allow grease to go in from the Zerk fitting, and there's reservoirs cut on the inside to retain it. This is extremely nice. It's not difficult to get a sway bar out of a vehicle to clean and re-lubricate these sorts of polyurethane bushings, but to be able to do it without removal or disassembly, wonderful. Now, this is a universal kit, so it's got slots on the bracket instead of precisely drilled holes, but they do perfectly overlap with the old bracket. There should be no issue. This fits in every way that it can fit. It was reasonably inexpensive and easy to get, and it looks like it'll be a good quality product that'll last a long time. I'm not even going to try to source rubber ones now. But in addition to those, there are the end links. The end links contain bushings in them, but they're generally sold as a kit. When you buy an end link kit, you get the necessary hardware, washers, nut, bolt, bushings, etc., etc. And there's a couple of different varieties available. For a stock rubber style replacement with the rubber bushings, the part number is Moog K3124. For polyurethane, it's K700541. In addition, there's polyurethane manufactured by a lot of companies. For instance, these are Prothane. I'm probably going to be ordering rubber ones for myself. Now let's talk about the strut rod, which is probably the most interesting component here. The bushing is like a large rubber biscuit that attaches here at this threaded portion. And, luckily enough for us, it is a direct crossover, exact part number, as a 1967 to 1973 Ford Mustang. Now there's some other vehicles that it also crosses over, I believe some other Ford models, but the Mustang name is definitely easiest to find. And this is what it looks like. Two large pieces of rubber inside a steel sleeve. And as you can see, these bushings are, well, a little deformed. Along with that, they're cracked, they're separating, but hey, they haven't failed completely. Now, there's a lot of different options available for replacing these. I found several. The first, polyurethane. This is a prothane one, but lots of different places make them. Widely available, easy to get, and fairly inexpensive too. Now, something to consider is that these bushings originally came with some large cupped washers, but they have a tendency to collect dirt and water and pit and rust out. So if you can get replacements for these, it's probably good to do. They cup around the rubber like this and hold everything in place. There's some information that says that one of them should be flipped. It's not really important. They exist. Let's say you don't want to go with polyurethane. Your old ones are bad. What else can you get? Well, there's these. These are sold by Mevotech, Dorman, FVP. Pretty much every parts outlet has these style of strut rod bushings, and these are supposed to be a direct fit. The nice thing is, they're apparently made out of rubber, and they come with two new cupped washers. Zinc plated, yellow passivated, very nice. Not quite as hefty as the original washers, but I'm sure they're just fine. In addition to that, they come with a new steel sleeve, just like the polyurethane does. Pretty good. And they come with this interesting step-down cupped washer thing. Now this is an unusual design. Apparently this is an upgraded design over just a rubber bushing, and this does something to stiffen the bushing or has some other purpose. The problem I found is that this doesn't fit very well in the Eagle brackets. I imagine it might fit better in a Ford Fairlane or a Mustang or something like that, but I doubt it since these are supposed to be the same size. In addition, there's some issues with the formulation of rubber for these, which we'll get into later. But you can tell these from every manufacturer because they have an F stamped in them. That's often seen in their pictures, and on the inside they're concave. You're going to see that a lot if you start looking for these. The good news is they're cheap, they're readily available. Now, there is another option out there, which is what I'll be going with, and we'll get into why a little bit later, but it's these Moog parts. Now, the part number for this is K8157. It may have formerly been K3090. There's some debate on that matter, whether there were subtle changes or updates or whether they stopped production or just changed the part numbers. Nobody's really sure. What I can tell you is that these are still available. They're hard to get. It took me 3 weeks to get these, and every supplier that I looked at during those 3 weeks was out of stock. And once these shipped to me, actually shipped, every supplier got restocked, but we're all saying they were low on stock. So these seem to be in quite some demand at the moment. We're going to get into these a little bit later, and the rest of the strut rod bushings, and talk a little bit more about them, what materials you want to use and why. But this is what I'll be going with. Now, there are a couple of odds and ends we need to touch on real quick. There is an isolator pad that goes on the top of the coil spring that insulates the body from the spring. It just serves to dampen any noise, any movement, anything like that. Now, originally it was rubber. I could not find rubber replacements. I'm sure they're out there. These are probably the same size as a bunch of other vehicles, but no manufacturers seem to have that information available. But part of the prothane kit that I bought a long time ago contains these. Now these are polyurethane, but they're quite flexible. So those go right on there, should be a direct fit. If this doesn't work for some reason, if it squeaks, if it falls apart, if there's another problem, I'll probably try to make my own. There's just two different thicknesses of rubber. This doesn't seem very difficult. You know, it's not a very critical component. It's just like a noise insulator. So in addition to that, there's a couple of other small bits and pieces. We've got bump stops, which are Moog K3180. Now, the bump stops on this vehicle were originally rubber. These are rubber. Polyurethane's available. I'm going to go with these. I like a nice cushy bump stop. If I'm going to hit the bumps, you know, hey, soften it out a little bit for me is what I'm saying. Polyurethane would be just fine, though. It would probably last longer than this. The final components are those little washers and spacers and things like that that go on shocks. Shocks usually come with a little kit with washers and rubber pads and things like that. Some of the Prothane or other polyurethane kits come with replacements for those in polyurethane. I'm probably just going to use the rubber. Came with the shocks from the shock manufacturers. I don't really care about stiffening up the shocks. They're going to be just fine. But obviously that's up to interpretation. Now that we've discussed rubber OE style replacement bushings, let's talk about the elephant in the room. Polyurethane versus rubber. Why would you want to use one over the other? First, let's talk about the pros of polyurethane. Number one, it's much easier for you to install at home than a rubber bushing, especially if you don't have a hydraulic press. Now, presses are pretty cheap these days, but still, it's easy. You get to keep the existing bushing in place. You just heat it up, melt out the rubber, knock it out, maybe clean it up a little bit, and then press the polyurethane into place with a vise or even with your hands, depending on how well it goes. And there's no special tools, no special techniques required. You don't really have to worry about hurting anything else like you do when you're using a 20-ton press. So it's very easy to install at home. The second pro is that you don't need to put the weight of the vehicle on the suspension before you tighten up the suspension bolts. With a rubber bushing, it's important that the vehicle be at its rest height before the bolts are tightened. Polyurethane, not necessary. You can slap these bad boys in, tighten up the suspension, keep the car on a lift for weeks, months, years, drop down on the ground. There's no need to do anything different. Just put it in. It's good to go. What allows that is the next pro of polyurethane. Free articulation. There's no stretching, twisting, pulling that occurs with a polyurethane bushing. There's just rotation. This inner sleeve and the polyurethane rotate relative to each other, along with the control arm or whatever else is attached to it. Now that's a serious pro. It means that there's less heat buildup, less inefficiency, less potential binding. There's no spring back like there is with a rubber bushing. So if you're trying to dial in very specific spring or shock settings, this is going to be the way to go. It just rotates. It works. The next pro of polyurethane is that it's a very stiff material. Now, it's not soft. It's almost more like a plastic. And that's fantastic when you're dealing with something that's supposed to rotate because it keeps it from flexing or deflecting. If you're talking about something like a control arm, which is only supposed to pivot up and down, then preventing it from moving actually keeps your alignment in better shape while you're driving. Or even over the course of years and years, where rubber will deform and change and assume new shapes, polyurethane is much more resistant to that. It's going to want to stay just like it is, except for that rotational movement. The last pro of polyurethane is it's a very hardy material. It's weather resistant, which UV, ozone, water, salts, and acids, it's pretty good at resisting those. Along with heat, chemical attacks, it doesn't degrade naturally like rubber does, which is something to consider, especially if you're, driving on salty roads, or if your bushings extend into your engine bay and might be contaminated with oil at some point, or they're near your headers and they might get some heat on them. Polyurethane could be a better choice. All that said, let's talk about the cons of polyurethane. The first is, well, a little bit anecdotal. You see, polyurethane is pretty easy to manufacture, and that's great for creating low-cost parts, or making parts at home, or doing small runs of discontinued things, but it really allows people to make polyurethane replacements for just about anything. And a lot of times, in my personal opinion, they don't fit very well. I've come across more than a few bushings which are oversized, their diameter is too large, or the length is too long to fit in the application, and they require some kind of sanding down, cutting down, And even reputable manufacturers, well-known polyurethane manufacturers, can suffer from this problem. They're not taking the necessary time to think about and measure and understand the application. In addition, the qualities of polyurethane, the stiffness, the resistance to movement, mean that they have to be much more precise. A rubber bushing is much more compliant. Even if this is off a little bit or the length is a little bit too long, that rubber is going to squish down. It's not a big deal. But in addition, this is a more expensive component to make. From a reputable manufacturer of rubber versus polyurethane, the rubber components will almost always fit better. They are intended to be a OEM style replacement, whereas the polyurethane is by its very nature sort of a DIY hack, mod, if you will. It uses the old sleeves. You know, there's a lot of assumption in polyurethane that doesn't exist in a bushing like this. Like I said, that's a little bit anecdotal, but it's something I've found quite a bit of. Now, the other downside to polyurethane is that they need lubrication. They need to be lubricated. Now, perhaps you can get away with it. There's a lot of information on the internet about wrapping Teflon tape or using various kinds of molybdenum paste or shims or graphite or whatever to get away from the need to relubricate these. But really, the point stands. These need lubrication. If they're not properly lubricated, they're going to wear out. And they're going to bind. And they're going to squeak and squawk and make all kinds of noise. Rubber bushings, on the other hand, require no maintenance. They're a maintenance-free item. You pop them in. If you want to, you can clean them off every now and then, but you don't need to touch them again until they've failed and you replace them. Once they start to crack and dry rot, you just switch them out. Polyurethane, especially if you're driving in dusty or dirty conditions, can get caked with garbage. Debris, sand, small rocks and things of that nature can get into here and turn it into a sort of a grinding paste. It'll get stuck in the grease. There's no real seals on the outside of this to prevent that from happening, and it'll just eat away at the bushing very rapidly. Or another possible circumstance is that if you're in a very wet area and you're going through a lot of puddles and you have a low-hanging bushing, that grease can and will eventually wash out under the pressure of that water. Now, it may take years, but it is eventually going to happen. And unfortunately, most polyurethane bushings, especially for like a control arm, don't come with a way to re-grease them other than to disassemble the component, take them apart, clean the old grease out, and put new stuff in. Now, yes, some do come with things like Zerk fittings. For instance, the new sway bar bushings that I got have those already installed. And yes, you can modify the old sleeves that these are going to go into to hold something like a Zerk fitting. But now we're talking about even more DIY. This is no longer just a part that you put in. You're now drilling and tapping and putting additional parts in. And still, even with all that done, you have to relubricate them from time to time. And let's also not forget noise. One of the biggest downsides to a polyurethane bushing is the transmission of vibration. These are much less spongy and absorbent than a rubber bushing. You're going to get additional vibration and noise to the driver or to your passenger. Now, bushings in different vehicles do different things. Different positions in the same vehicle do different things. Is every single polyurethane bushing the same in the way that it transmits noise and vibration? Absolutely not. For instance, it's widely known that sway bar bushings transmit very, very little additional noise or vibration into the cabin, but something like control arm bushings have a tendency to transmit quite a bit. I believe that covers most of the differences between rubber and polyurethane. There's a lot of pros to polyurethane, but there are some serious cons. Rubber is still used by every OEM manufacturer for most bushings. Let's keep these pros and cons in mind here as we go through the suspension components and see if there's anything that could be improved by replacing the rubber bushings with polyurethane. Let's start here with the spring perch. Now, we've already decided there's no rubber available. Polyurethane is really the only option without serious modification. So, polyurethane. But if we consider how this is supposed to operate, we can more closely examine why polyurethane might actually be the best option, even if rubber was available. Now, the operation of the spring perch is extremely simple. It attaches to the upper control arm. It stays vertical while the control arm pivots, angles differently. So it just rocks back and forth a few degrees. It's really not a big deal to it. But something else that it does is it supports the entire weight of the vehicle through this bushing. Because the coil spring sits on top and the vehicle's on top of that, pressing down. Now rubber is compliant, like we talked about. It has a tendency to squish and it has a tendency to conform, much more than polyurethane does, or any harder material. So using a material that has a higher diameter or is harder would probably help keep this pin more centered. Is that really going to matter? Maybe, maybe not. But what we can assume is that over the long run, the years and years of use and abuse, that polyurethane probably won't sag like rubber will. Rubber has a tendency to permanently take on new shapes. Polyurethane is a little bit more resistant to that. So hopefully this will actually last quite a bit longer than a rubber replacement would, and it'll keep a better height of the vehicle over a longer period of time. In addition to that, well, we don't have a choice. Already said that. All right, no rubber, we're going poly. It'll pivot, it'll be good. Now let's talk about the upper control arm. The upper control arm, very similar to the spring perch, it just pivots. It goes up, it goes down. It's got two bushings, and these bushings actually extend into the engine bay a little bit. So they're exposed to maybe a little heat, maybe some chemicals, things that might be bad for rubber. Might be nice to have something a little more resistant. That said, I'm going to be using rubber for all the reasons we talked about. It's going to be a softer, more compliant ride, and I won't have to modify these with Zerk fittings, and I won't have to take it apart to re-grease it. I'm not interested in any of that. So I'm going to be going with rubber, but polyurethane is an excellent choice for this application. Now let's look at the sway bar. As we already talked about, I could not find rubber replacements for the original mounting bushings, so I got polyurethane. And those specific ones come with Zerk fittings. They fit well, they've got new brackets in them. I have no complaints. Those should be easy to maintain, they should do a good job. For the end links, I'm going to take the opposite tack. I'm going to go with rubber. And the reason for that is simple. The end links are exposed quite a bit to road debris, dirt, grime, water, and I'd really rather not try to get in here and paint fresh grease in there and clean out the old gunk that's going to build up. So I'm going to go with rubber end links. Polyurethane, good choice, not a bad choice at all. I'm going to not deal with that. Okay, with that taken care of, let's talk about the real meat and potatoes of the matter here. Strut rod and lower control arm. Now we talked a little bit about how the caster and camber adjustment is done. So this is where most of our adjustment takes place for the vehicle. Now here's the thing about this. You might look at this lower control arm and assume, as most people do, that it's just intended to pivot. There's a single pivot point, it just goes up and down with the suspension, much like the upper control arm operates. But if we take a look at the design, it's clear to see that's, well, it's probably not true. And we can tell that because there's only a single bushing. If you want to keep a piece that's supposed to pivot from rocking or bouncing or swaying or any other movement that you don't want to do, you need to have a second mounting point. Upper control arm has that. The lower control arm, well, it doesn't. What it does have is a strut rod. The strut rod moves in an arc. The end goes up and down, and the angle changes. And the effective length increases in
decreases as it swings closer and farther away from the control arm. The exact same is true of the lower control arm. Attaching them together means that each has to accommodate the arc of the other in order for them to move at all. If there were no bushings, there would be no movement. For the strut rod, this means a slight twist, a left and right movement when viewed from the front, and varying amounts of compression on the bushing as it pushes the control arm forwards and backwards through the arc. For the control arm, the same movements must also exist. There's a twist that has to occur, a left and right, or forwards and backwards in relation to the vehicle, positive and negative caster, and varying amounts of pressure on the bushing as it forces the strut rod along. Not to mention the all-important up and down pivoting that these bushings are meant to do. They work in tandem, and they need to be considered together as a pair instead of separately. So what does it actually look like if polyurethane is introduced? Here I'm using the 40-year-old original rubber strut rod bushing, which is now so worn out that it's way softer than it should be, and for the lower control arm, a polyurethane bushing. The resistance to movement is immediately apparent. Even with the overly compliant strut rod bushing, it's taking a good deal of force to move this. But that's with no camber adjustment. That's just letting the lower control arm sit exactly where it happened to end up. Introducing approximately 2 additional degrees of positive camber causes even more resistance. It's not a huge amount, but it's definitely more. You can't tell that very well from watching me move this, but it's very obvious by feel. And this is not even close to the end of the camber adjustment. So what happens when that old and worn out rubber strut rod bushing is replaced with polyurethane? Oh my God. Oh, it's not even, can I stand on this? I am literally standing on this. That is my weight on the lower control arm and the strut rod, and it is not touching the ground. Okay, so where does that leave us? Well, for the lower control arm bushing, I recommend staying away from polyurethane. Rubber is really the only material that has the necessary compliance that this requires. As for the strut rod bushing, well, it's not so cut and dry. Since we're already doing some testing, and since there's multiple styles available on the market, let's pull this off the vehicle and set up a little test rig and try to get an understanding of how these differ. It's difficult to see the difference on the vehicle other than no movement or some movement. To that end, I've put together this little test rig. This is the strut rod mounting bracket that goes on the vehicle. It's upside down and backwards here, but it's nice and stable in the vise. And this is the strut rod. And I've got a little indicator that's been vice gripped onto the end here. This is what we're going to do. We're going to swap out each of these bushings. I'm going to put a measuring device, and then I'm going to put this weight on every single one of them. Probably weighs 3 pounds, 2.5, doesn't matter. It's the same weight for all of them. Put it right there, measure the amount of deflection that each of the bushings has. First up is the factory rubber bushings. These are dry rotted, they're cracked, they're way past their useful life. They're probably going to be an outlier, but let's go ahead and test them anyways. An important note about the test rig here, it doesn't really matter what numbers this indicator points to. The only thing we care about is the difference. So for instance, the rubber bushings are starting out at about 168 millimeters and then going down to about 152 millimeters. If they started at 178 or 188 or 200, it doesn't matter. All we care about is that there is a change. The change here is about 15 to 16 millimeters. Next up is the Dorman Mevotech FVP, your run-of-the-mill
quote-unquote rubber replacements. And the change is 1 to 1.5 millimeters, which is a significant difference from the factory rubber. And just for kicks, here's a shot of the bushing. This is how I installed them because they don't come with instructions, so I'm just assuming. You guys disagree? Did I do this wrong? I don't know. You tell me. And third, we have polyurethane. Polyurethane bushings we saw on the vehicle. The change is about 2 to 2.5 millimeters. And finally, the Moog upgraded rubber bushings, the ones that are different than the rest. They've got their own built-in washers. They're the ones I'm going to be using. The change is 5.5 to 6 millimeters. Well, if I'm honest, the results of that test were pretty much what I had expected, and you can draw your own conclusions, but for me it does validate my choice to go with these Moog upgraded replacement bushings. I still have more to talk about. We haven't even touched on lower ball joints yet, but I'm going to have to split this up into 2 parts. So this is going to be the end of part 1, and part 2 should be out in a few days. I want to say thank you for watching if you got this far. I understand that I can't cover everything, but hopefully I've given you at least a primer course, have a little bit more understanding of how bushings work and what to choose, and if you were looking for a special part number, maybe you found it. But anyways, thank you for watching, and we'll see you in the next one.